Okay, so now we're going to talk about using the graphs of trig functions to solve real-world problems. So we talk about, we didn't really talk about it, but the book did. Have you ever observed the beam formed, starting right here, the beam formed by the rotating light of a police car. They don't really have those anymore. Now they're kind of flashing lights. Strobe lights gets people's attention more, but if you watch a movie, they might have the spinning light on top of the car. I wondered about the movement of the light beam itself across the wall. So the periodic behavior of the distance of the light shines as a function of the time is obvious. How do we determine the distance? We can use the tangent function. So suppose y equals 5 tangent of pi over 4t marks the distance in the movement of the light beam from the top of the police car across a wall where t is the time in seconds and y is the distance in feet from the point on the wall directly across from the police car. Find and interpret the stretching factor and the period. So our stretching factor is the 5. Is the absolute value of A, absolute value of 5, which is 5. So that means that the beam of light will have moved 5 feet after half a period. After half a period. And then the period itself, period is going to be pi over b, absolute value of b. So pi over 4, which would be 4. So that the period is 4 seconds. Okay. And so B says graph the interval from 0 to 5. So since half the period is 2, we'll have a vertical asymptote. Change colors to red. At 2. I had to make these graphs on a graph generator on the internet. And then 4 later, or at 6, is the next asymptote. Okay, so our crossing point, by the way, going back by 2 puts us here. No, it's 4, so it should put us here. Okay, so let's take a look here. Our normal crossing point, let's go back to blue. Well, it's going to be 0. It's not shifted, so the midpoint of the period it crosses. Between that crossing point and the asymptote, that's where it would normally be 1, but this one is shifted to by 5. Let's make it that. Same thing here. So this one would be down here. Okay, so we have a graph like so. Now they said just from 0 to 5 I'm doing, looks like -3 up to 6 up to 8. Comes up like so. Okay, that's how that one would work. And that'll be the end of this video. I spoke to assume there's still part C, evaluate f of 1 and discuss the function's value at that input. So for C, f of 1 is going to be 5 times tangent of pi over 4 times 1. So that's going to be 5 times tangent of pi over 4. Tangent of pi over 4 is 1, so 5 times 1 is 5. So, I mean, that's the distance. After 1 second, it's 5 feet away. Okay.